Hey everybody, this is going to be our first Unit 10 video. We're going to be talking about sequences and series. So a sequence is really just a set of numbers that have a particular order or pattern to them, and each number within a sequence we call a term. So I've got one down here below. Now each term is denoted as a subscript n, where n is just really the position of that term within the sequence. So for example, this would be a subscript 1 because it's the first term in the sequence. 5 would be a subscript 2. 17 would be a subscript 5, and so on. So that little subscript is really just telling you, like, hey, this is the placement or the position that this number has within the sequence, okay? So that's what we call the term number. Now, we're going to see two different types of formulas for sequences. We're going to see recursive formulas, where the formula that we're using to generate the sequence is really dependent on knowing what the previous term or maybe multiple terms are. Okay, so if you look at the example I have below here, we know what the first term in the sequence is. We know it starts with 6. Okay, but to get all of my other terms, I'm going to have to use this formula. And what I want you to really notice is it says a subscript n. Okay, so the term that I'm trying to find is equal to 2 times a subscript n minus 1. Well, if n is the one I'm looking for, then n minus 1 would just be the term that comes before it. So if I'm looking for, a subscript 2, my a subscript n minus 1 would really be equivalent to a subscript 1, okay, because it's 1 less than the term I'm currently looking for. Now, this part right here, okay, for n is greater than or equal to 2, that's just saying that you don't start using the formula until you start looking for your second term or higher, because we already know the first term, right? I can't use this formula to find my first term. It only works for finding the second term and up. So let's go ahead and find a couple of these, okay? Sequences usually go in curly brackets, so we start at 6, and then to find the second one, I'm going to do 2 times the first term minus 5. So 2 times 6 is 12, minus 5 is 7, okay? So now I'm finding the third term. The previous term is going to be the second term, which is 7. So when I'm finding the third term, I'm going to do 2 times 7, which is 14, subtract 5, I get 9. Okay, when I'm finding the fourth term, I'm going to do 2 times the third term, which is 9, so 18, minus 5, we get 13. Okay, and we could continue this pattern forever. Okay, we could just keep on doing it. So keep in mind, recursive formulas, you need to know the term that comes before it, okay? If I wanted to find the 100th term of this sequence, I would literally have to find every single term that comes before it. That would be the only way to make that calculation. The other type of formula is what we call an explicit formula, and these are much more useful for finding terms farther down inside of your sequence because they don't require you to know the previous terms, okay? Explicit formulas are really dependent on the term number. These formulas really look more like a function where n is your variable, okay, your independent variable. So let's say I wanted to find the first term in the sequence given by this explicit formula. If I want to calculate the first term, then I'm going to plug in 1 for n. Okay, so it's more like a function. So that would be 2 times 6, which is 12. If I wanted to find my second term, now I'm going to plug in 2 for n. I know 2 plus 5 is 7, so let's see, 4 times 7, so this would give us 28. And we could keep on going, okay? Explicit formulas. I could jump and immediately find the 100th term if I wanted to. We don't need to know the previous terms, which makes it super nice if we want to know something further down the line inside of the sequence, okay? And then as usual, if we wanted to, we could throw these in the curly brackets here if we're trying to generate the whole thing and keep on going. The other nice thing is when you have explicit formulas like this, if you want to really quickly generate the terms, plug it into your calculator. Okay, if you plug it into your calculator and then go to your table, you can find a whole list of the terms for you. So these ones are really nice. Okay. Now, the other thing we're going to be talking about is series. And a series is really just taking all of the terms in a sequence and adding them up. So there's a couple different ways you're going to see it. Okay. The first kind is you're going to be given a sequence like this, and you're going to be asked to find a partial sum, which is usually using this notation. You've got the capital S with some subscript. This means find the sum of the first 4 terms. So that means, even though this sequence goes on forever, I just want to know what these first 4 added together are. Okay, well, if I do 4 plus 7 plus 13 plus 25, I'm just going to get, what would that be? 4 plus 7 plus 13 plus 25, I'm going to get 49. Okay, if I wanted to find the sum of the first 5 sequences, I would get 98. Like, you can just keep going. Okay, it's just a coincidence that this sum is equal to that 5th term there. Okay, don't be paying too much attention to that. Partial sums, you're just finding the sum of the first however many it tells you. Now, the more complicated way that you're going to see that is when it's written in what we call summation notation. It's just another way to represent a series, and it uses the Greek letter sigma to denote that we are taking a sum. Okay, so when you're looking at this notation, the 2 in here would represent the actual formula for your sequence. Like, this is the formula that we're going to use to generate the sequence that we're going to be summing up. And then notice there's a number on the bottom and on the top. The number on the bottom is the term number that we're starting at. And the number on the top is the term that we are stopping at. Okay, so if I wanted to find the series, I would find the first 5 terms in the sequence generated by this formula and then add them all together. Okay, so let's do that. So to find my first term, right, I'm doing 2 times 1, and I'm adding that with the second term, which would be 2 times 2. Adding that with the third term, which would be 3 times, 2 times 3. Adding that with the fourth term, which is going to be 2 times 4. And adding that with the fifth term, which is going to be 2 times 5. Okay, so the numbers that I was plugging in were my turn numbers. Okay, we're using that explicit formula to generate the terms, right? The sigma is denoting that we are taking the sum. So that's what tells me that I have to actually add all these up. Okay, so if I do that, if I add all of these up, if I make that calculation, we're going to find that the sum is 30. So this is the other way that you are going to see series represented. Now we're going to get a lot of practice with these in class. I just wanted to kind of give you a little introduction to what sequences and series are. Please let me know what questions you have, and have a great rest of your day.